Why is the double-slit interference experiment a terrifying physics experiment enough to overturn worldviews? At first, physicists were always struggling with one question: is light ultimately a wave or a particle? In the 17th century, Dutch physicist Huygens was the first to propose the wave theory of light. He believed that light is a kind of wave, and its interference phenomenon is the most direct proof. Two beams of light crossing would produce interference fringes. But in the 18th century, Newton, however, believed that since light propagates in straight lines and reflects when it encounters obstacles, then light must be a particle. And given Newton's status in the physics community at the time, the particle theory led by Newton dominated the entire 18th century. Afterwards, the physics community was deeply divided on whether light is a wave or a particle. At the same time, both the wave school and the particle school developed their own theories, and both firmly believed their theories were correct. Until the 19th century, British physicist Thomas Young, based on the wave theory of light, designed the famous Young's double-slit interference experiment. He made two slits in a barrier and thought that if light were particles, then when passing through the two slits, there would appear two bars corresponding to the slits. If light were waves, after passing through the two slits, they would become two waves and interfere with each other, just like two ripples on the surface of a lake appearing at the same time. And the experimental results were exactly as Young had predicted. Clear stripes, like zebra patterns, appeared on the screen. This not only gave the wave school a temporary victory, but also showed the world that authority is not the same as truth. But with the rise of quantum mechanics, this experiment once again became puzzling, because Young's interference experiment used a photon stream mode, so the mutual interference between photons created the zebra-like stripes. Thus, physicists began a second experiment, switching the photon gun to single-shot mode, ensuring only one photon was emitted each time, and that only one photon passed through the slit each time, making it impossible to interfere with other photons. Theoretically, two bars should appear on the screen, but the experimental results were beyond everyone's expectations. At first, since the number of photons was small, the light spots on the screen appeared somewhat chaotic. As the number of photons gradually increased, interwoven bright and dark zebra stripes still appeared on the screen. And according to the wave theory, the stripes come from the interference of two wave sources created by the slits. But a single photon either passes through the left slit or the right slit. So with only one slit, what exactly is the photon interfering with? To answer this, physicists conducted a third experiment, placing a high-speed detector before the two slits to record which slit the photon actually passed through and how the interference occurred. Again, photons were emitted in single-shot mode. Through detection, it was found that each photon indeed passed solely through the left or right slit, without splitting in two. But just as physicists were puzzled about what a single photon was interfering with after passing through a slit, something bizarre happened. The stripes on the screen somehow turned into two bars. Later, after repeating the experiment many times, they found that when no detector was installed, the result always showed zebra stripes, indicating that light appeared in the form of waves. But when a detector was installed, the result became two bars, indicating that light appeared in the form of particles. At this point, physicists were astonished to discover that the nature of light actually depends on whether you observe it. This is the truly terrifying part of the double-slit experiment. To explain this bizarre phenomenon, in 1905, Einstein proposed the photon hypothesis in the photoelectric effect. Only then did people begin to realize that light possesses both wave and particle duality. And later, this evolved into one of the fundamental properties of microscopic particles in quantum mechanics wave-particle duality. That is, due to being measured or not measured, a photon exhibits two different forms, wave and particle. It is a quantum system in a superposition of different quantum states. Regarding this, the father of quantum theory, Niels Bohr, also made a famous remark. Before observation occurs, no physical quantity objectively exists. But at that time, many people did not agree with this view. Among them, Einstein was a typical representative. He believed that all matter exists in the objective world, and with the phrase, "God does not play dice," he rejected the randomness in quantum mechanics. And you, in front of the screen, how do you view this bizarre double-slit interference experiment?